All right, so taking a look at our schedule of events, you've still got another week until homework number 4 is due. And I know that you're making good progress on that assignment because I've already heard a few students, they've asked me to check on certain things and stop by during my office hours, so I'm glad that everyone's being industrious. On the 16th, we'll have our exam. And the format of that exam is it's going to be both problem solving and some short answer concept type questions. And we'll have 75 minutes for the exam. You can bring your computer because you're going to have some questions where you need to use Excel. You can prepare a formula sheet if you like. And I'm going to provide you with the factor equations as well as a factor table for any problem where I ask you to use an interest factor. Mm-hmm. Yeah. Now what I'd suggest you put on that is, remember, when you use Excel for solving an exam problem, you need to start from a blank workbook. So if you don't remember how to do present worth analysis on Excel, maybe on the formula sheet you could give yourself a few reminders on how to set that up. Or if you need to set up kind of a template or a step-by-step for yourself on how to solve for future worth on Excel, then that could be something that you could include in your formula sheet, is just a description of what you're going to do once you start a blank workbook in Excel.
So there will be Excel in the exam?
There will, yeah. You do need to have access to Excel for the exam.
Are we allowed to write concepts on the formula sheet?
Yeah, you can put anything you want on the formula sheet.
What kind of concepts are you looking for on the exam?
Well, it wouldn't be anything other than what we've covered in class, because there's not a required textbook for this course, and I haven't given you any assigned readings. So it would just be the concepts that are related to the lecture.
Can we get like any exam guide or something?
There's no exam guide. Yeah. I guess you could say the exam guide is the notes that's available on Blackboard. All right, so then following that, 1 week later is when project number 1 is due. So that's the schedule. Remember that in class last time, on Thursday of last week, we talked about present worth analysis, which is different from the present worth method. Present worth analysis is when we're comparing alternatives. And so we're going to do a similar thing today with both future worth and annual worth. You already know how to calculate the future worth of some value, and you know how to calculate the annual worth, but we're going to extend that into decision making and talk about how things like least common multiples, contract services, and all of that applies in these new scenarios. So just to revisit very briefly the decision criteria of present worth analysis, remember that the decision criteria is you should choose the alternative that gives you the most profit. So if you discount all of the cash flows at the MAR, minimum attractive rate of return, then you'd choose the alternative that has the highest non-negative present worth. But if you've looked at the homework assignment, you already know there are some situations where only the costs are described. Like you don't know how a piece of equipment is being used. It's generating revenue, presumably. That's what justifies the purchase. But when you're comparing two alternatives and all you know is the cost information, then you should choose the alternative that is the least costly, when everything is discounted to the present. All right, so you remember our 3 techniques for making sure that things are compared across the same study life. And so we have to compare alternatives for the same number of years. You can't have one option that's 7 years and one option that's 5 years and to just find the present worth of each of them, because there would be 2 years that the equipment isn't in use. And so in order to make it so that the items have the same number of useful lives, you have to either use LCM. I haven't handed that out yet, so just, yeah. You use the least common multiple approach to cycle the alternatives where you're assuming that the item can be acquired more than a single time. Contract services is the alternative which takes the shorter option and lengthens it. And from the homework, let me give you a hint. If you are renting the item, you still need the electricity to operate the item. So let's say that you bought the item and it lasted for a certain number of years, but in the problem statement it told you the operation costs. In the years after that first item that you purchased, when you're going to lease the equipment, it's going to be the lease expense, but then also, whether it's gasoline, electricity, some sort of operating costs are going to apply on top of the lease. So that's the contract services approach for making sure that the two useful lives are the same. And then finally, early termination is where you take the alternative that was too long and you truncate it by selling the equipment. Now look, here in this diagram, we're only selling the equipment one time. So we could have held on to the item for 9 years in total, and then it would have no salvage value. But instead of holding on to it for the entire life, you're selling it in the year that terminates with the same year as the shorter option, option A. So I may give you a table of what the equipment is worth in year 1, in year 2, in year 3. You're not selling that equipment each year. I give you that table simply so you'll know what its value is in the year that you do need to sell it. All right, so that's revisiting the present worth analysis. Now in future worth analysis, today it's exactly the same mindset and criteria as present value analysis, except for you're taking the cash flows to the future. We still have to have the same study period, meaning it has to be the same number of years. The alternatives have to end at the same time. But the application here, the reason why you maybe would calculate future worth analysis is that there are some projects that take a long time to construct. And so instead of it just being one expense, like purchasing a new car now, you could pay a single lump sum and instantly have the car. But the cost of constructing an airport, for example, is something where you may pay for year after year, and it may be 5-6 years until the project is complete. And so you may want to know what is the lump sum that has to be paid to a contractor who's been incurring these intermediate costs during construction, plus the time value of money. So common applications would be alternatives that take longer than a single year to construct, or projects where you'd expect to sell it before the end of its useful life if you wanted to know an appropriate sales price for an item. You could calculate the future worth of the equipment to know in some years after now how much it should be sold for. The decision criteria is when you're compounding the cash flows to the future. Remember this verb, which is in bold here. Compounding means the amounts are taking forward in time and the amounts are increasing. Does anybody remember what verb we use to talk about when you are finding the present worth instead of compounding? Discounting, good. So discounting is when the amounts are getting smaller, moving backward in time. Compounding, moving forward in time, the amounts are getting larger. So you'd choose the alternative that has the highest non-negative future worth. Or if it's an option, I thought there was another thing here. If there was an option that is only the costs, then it would be the alternative that is the least expensive if you don't have the revenues included. Okay, so let's begin with the future worth analysis. Are there any questions, by the way, before we get started on the decision criteria? Okay, so you can see we've got two cash flow diagrams, option A and option B. Option A lasts for 9 years. Option B lasts for 3. So already when you see that, probably you should be thinking, oh, least common multiples. Because we don't have any information here about salvage value or resale, so we can't do early termination. And there's no contract services, no lease options available. So it's saying here that in option B, you'd have to conduct dredging operations every 3 years. And so it's a process that has to be repeated occasionally to open up the port. So what we're going to do is with Excel, find out what is the future worth of both options, option A and option B. So this is good practice. Number one, because you are getting some practice with LCM. So my recommendation is you should take your pencil and write on the cash flow, like on the paper, write when is the purchase again, when is the revenue, show yourself that cycle through the entire 9-year period. And then once you have the cash flow diagram written onto the paper, then we're going to translate that into Excel and find the future worth of both. Now, one last discussion point before you get started. When we're finding future worth, what is NPER?
It's the backwards periods.
It's the backwards periods. And why is that? If we're taking all of this to year 9,
You're in year 0, so
year 0, it needs to move 9 periods to get to year 9. And it's in year 1, it needs to go 8 years to year 9. So we've got the time column and then kind of like a reversed time column. Because we want to reference the number of periods is how many years into the future does any particular row need to go. So just that reminder about add time, the reverse time column, amount, and then FV of amount. option B has a smaller negative value than option A. So what we want to do is choose the option that is the least costly of the two. And option B is least costly. So if this is a must-do kind of a project, then you'd choose option B. But if it's not a must-do, then neither of them should be done because they're going to be losing money. Okay, I've already drawn the cash flow diagram on the whiteboard. So the issue here is we don't know the appropriate purchase price for option B. So I'm going to have the interest rate up here, 0.045%, and then since we're finding the future, we're going to need to have years until year 11, amount, and FV of amount. We're going through 11.
Here's what I've got. Oh, your 25,000 should be positive. Yeah. That's income coming in, so it should be positive. Does that make sense?
Okay, this problem's a little bit tricky, the second one, because what they're saying is we want to find out how much your uncle should pay so that option A and option B are equal. And why that's useful information is that eventually the seller is going to have some price in mind. And what your uncle should know is what he's willing to pay in order so that option A and option B are the same. So if the seller quotes a price that's lower than what he's calculated, then that means he's going to make more than the 4.5% rate of return. So let's say, for example, what if option B costs $100,000? So I'm going to put in $100,000. Okay, that brings down the future amount, the total future amount. We're going to find out what is the price that makes this and that equal. So let me write it in here. So our goal seek that we're going to do, find the initial purchase price for option B that makes the sum of the future values for option B equal to the sum of the future values for option A. So in other words, I'm going to highlight the things I'm looking at here. I want this and this and this are going to be the main things that I'm playing around with and looking at. because I'm finding out the future value of all these amounts. And I already know option A is kind of already determined, that this project is a pretty good option, option A. Your uncle's minimum attractive rate of return is 4.5%. And if that's the minimum attractive rate of return, this still has a positive future worth, which means that paying $250,000 for it gives you even more than the minimum attractive rate of return. We could find out what is the rate of return that's actually being yielded by playing around with the interest rate until this is equal to 0. But the fact that it's above 0 means that you're earning more than the minimum attractive rate of return for option A. So now what we're going to do is we're going to find out what is the purchase price for option B that makes the sum of the future worth of the amounts equal to the sum of the future worth of the amounts for option A. So here, data, what if analysis, goal seek. And so the objective is for this cell to be 51046 by changing the purchase price. So what is the purchase price that would make it so that these two projects have the same value? So your uncle should in his mind have the idea of $181,768 is the equivalent purchase price for option B to make the two alternatives equally desirable. At the different speed on Excel. So if you're getting these really quickly, that's great. If it's not coming quite as naturally yet, that's okay. You're going to develop the proficiency with Excel. My recommendation is just go back and review the lecture later to make sure that that you can solve these things quickly. You know, because we've got an exam coming up, and if you know it but you can't do it quickly, then that's going to put you at a disadvantage. And so the best way to get this is just practice. You know, work the same in-class exercise again until it becomes natural for you. Okay, so that is future worth analysis. Let's talk about annual worth analysis. So here on the screen I'm showing you a cash flow diagram. Here's what it looks like to me. That you're paying some money to buy equipment, and then you're spending a little extra money to refurbish it. Here are some operating costs, and then at the end of some time period there's a little bit of salvage value left over when you're disposing of the equipment. Annual worth analysis is translating this cash flow diagram where there's a different amount each year into an annual series where each of the amounts are equal in magnitude and it's an unbroken chain. So it's just annualizing anything that isn't already an annual basis. So on this cash flow diagram, the first one, 0.9, I presume this is millions of dollars, 0.9 is already an annual series. But there's a single future value that needs to be annualized here in year 8. There's another single lump sum value in year 1, a lump sum value in year 0. So these three amounts, you have to convert it to an annual basis and then combine it with the amounts that are already in the annual basis. Now, one of the nice things about annual worth analysis is we don't have to bother doing things like contract services, LCM. If you have two pieces of equipment with different useful life, you can compare them without any further adjustments necessary once you solve it for the annual worth, because it already assumes repeatability. That's kind of baked in to annual worth analysis, is the idea that the item can be purchased again and will have the same cash flow in the future. So the decision criteria when you're applying annual worth analysis is that when you've used the MAR to compound all of the amounts into the future in an annual series, then you'd choose the alternative with the highest non-negative annual worth, or if there's only costs, then you'd choose the option that has the lowest of the annual costs. Now again, the benefit of this is that you don't have to make the two items have the same useful life. It already is assuming repeatability. Now, to do that though, you have to assume that, if you have two options with different useful lives, then you need to, because it's assuming repeatability, then you have to make sure that the services are needed for the entirety of the study period. And it's assuming that the selected alternative is going to be repeated multiple cycles, and the cash flows are the same through multiple cycles. So this is annual worth analysis. Analysis meaning that we're comparing alternatives. Capital recovery is a very important phrase. This phrase is going to come up on homework assignments and probably exams somewhere along the line. What capital recovery means is it means finding an annual series equivalent of an initial purchase price and a salvage. So a lot of equipment, you have to pay a lump sum amount to acquire it, and then at the end of its useful life, it has some residual value, either because you're selling it on the secondary market or you're just disposing of it for scrap. And when that's the case, the capital recovery is the difference, the annual difference between the cost and the salvage. And you'll notice that the arrow is down. And that's because the initial purchase price is almost always more expensive than the sales value at the end. There's only rare exceptions. If you think about like maybe a rare collectible car, like maybe a 1969 Mustang or a 57 Chevy, maybe in that case, the initial purchase price is smaller than its residual value at the end of some period. But almost every other piece of equipment costs more to purchase, and so therefore the capital recovery is going to be negative. So if we look at it as an equation, the capital recovery, the present value amount, which is the initial purchase price, you have to convert it to an annual series using the find A given P factor. So remember, inside the parentheses here is our standard notation for what we're solving for and what is known. Find A given P, where you're using some known interest rate for a certain number of periods, and the minus sign is because the purchase price is an outflow, and then plus the positive sign because the salvage value is a revenue. And you're finding the annual equivalent of a single lump sum future amount. So find A given F. So that's capital recovery. There's one strange kind of tangent related to capital recovery, and that is situations where the life goes on forever. Either it's a piece of equipment that lasts forever, or maybe a bank account that is going to be drawing interest and paying it out forever. So let's say that you put $100,000 in the bank, and you had a homework assignment where you had a certain amount of money, was at $100,000 in the bank, and then every year you take out $5,000, but it's only earning 4.5% interest rate, and it was 53 years. Right. Okay, what if you only took out $4,500? It would never go empty. So that's what this is. This is showing that if you're earning 4% interest, for example, and you want the revenue that you want to be able to draw forever, then A, the amount of withdrawals you can take every year, it's just the present value times the interest rate. So you could take out $4,000 every year for an infinite amount of time, because every year you're only withdrawing the interest. That makes, I think, pretty intuitive sense that if you're only taking out the interest, that the principal isn't touched, that then your income stays forever. So related to that is the idea that if you go into the tables and you find the 4% table and you look at find A given P. So that's what this is. This is find A given P. So if you look at the 4% table, it's getting lower and lower, find A given P. And if you follow it down through lots of rows, at 100 years, it's 0.0408. So if it's infinity years, then the factor would be 0.04. So it's approaching that 4% at 100 years. But infinity, then that A to P factor is 0.04. Okay? Now, here, the dashed line was the A. Remember, dashed line means the unknown. So if you were going to be withdrawing a certain amount of money forever and you had a known initial deposit. So now consider this cash flow diagram. What if you know that there's going to be some withdrawal that you want to make every year forever? How much should you have to deposit? So we're just rearranging that equation. In the previous slide, it showed you A equals P times I. This is saying P equals A divided by I. So the amount that you need to deposit into the account to provide for an annual withdrawal of $50,000, we would just have the $50,000 divided by the interest rate, which in this case is 10%. So 0.10, that means that you have to deposit $500,000. And then what happens at the end of each year? You have $50,000 of interest that's accumulated. It's immediately paid out. You're back to $50,000, and then each 1 year after that, then the amount of interest that's accumulated is $50,000. It's withdrawn. And so you don't have any compounding of the interest. The interest is being paid out. Okay, final related idea is there are some permanent investments which are things like bridges or dams where it's intended that they're going to have such a long life that it can be considered as permanent or infinite. Now, it's not actually going to last forever, but it may last for 150 years or 200 years. There are plenty of bridges that are more than 100 years old and they're still operating and in good condition. There's also a lot of bridges that are 100 years old and they're in terrible condition. But the point is that if we want to find the annual value of a permanent investment, we want to find out how much is it worth on an annual basis, then we can think of it as capital recovery, but there's no salvage. Remember that capital recovery on the previous slide had an initial purchase price, and then at the end of the cash flow was some salvage value. Well, if the item is never going to be disposed of, like the Brooklyn Bridge, then there's just only the annual equivalent cost related to its initial purchase price. So if you wanted to annualize how much they spent originally to construct that bridge, you just multiply the initial purchase price by the interest rate that applies. Okay. So let's take a look at, if you haven't already, problem number 3 on the annual worth analysis. Here's these two cash flow diagrams that we saw on the earlier slide. What we're going to have to do is, I've provided the factor table. This isn't an Excel problem. We're going to do this manually, the old number crunching way. I suggest that you start off by outlining the solution strategy. So tell me, what are the steps? Think of it as like a quasi-code. First, you're going to maybe take the future value and annualize it. So there is a lump sum right now in year 8. So it could be that your step 1 maybe step one is take F equals 0.5 at year 8 to annual worth using, okay, now this is where we have to think, what factor are we going to use? We're going to use find A given F, I equals 8%, N equals 8. Okay, so then step 2 is you've got this amount in year 1. I guess there's a couple of things we could do. If we were being silly, we could move it from year 1 to year 8, and then from year 8 to an annual series. That's a little indirect. Probably what I'd do is I'd move it from year 1 to year 0 and combine it with that 8 million that's already in year 0. So for example, take F equals negative 5.0 at year 1 to year 0 using, okay, now we have to think in terms of our language here. Find P given F, I equals 8%, N equals 1. All right. Step 3, take, it's 8 million, so P equals negative 8.0, and the amount from step 2 to A using, all right, and then we're going to do find A given P, I equals 8%, N equals 8. So with those steps, that's kind of the solution strategy we could use to annualize the $500,000 of revenue in year 8, the $5 million of cost in year 1, and the $8 million cost at year 0. So we need to spread all of those out and find like what is the annual equivalent and add it to the 0.9 million that's already as an annual series in years 1 through 8. So let me pause for a moment and let you do those calculations. The factor table is on the next page, so you can flip back and forth and get the factors that you need. So I've labeled these amounts, like the arrows. You can see I've labeled the arrows with A, B, and C. So that's how I kind of refer to what I'm doing. I'm saying like move A across the annual series using A/P. So that's going to be the factor of 0.9, that is the factor of 0.17401. And then moving C to the annual series, I'm using the factor 0.09401. Does the factor table really have that much precision in it? Wow, I'm surprised it's got so many digits. Find A given P, find A given F. Yeah, there's more digits there than I would have guessed.
Should we have rounded that off though?
Yes, we should. So how many digits? To 4 digits. And so I guess to be more appropriate, I should say it is 3,051,000.
So like right there at line B, where you have 5 million
Uh-huh.
times the 0.9259.
Yeah.
Should you round that answer off to 4 sig figs, or should you keep those?
Keep them and round it at the very end.
Okay.
Yeah, you round it at the very end for with whichever factor has the least number of digits.
Gotcha. Thank you.
Yeah. Okay, the fourth problem we have is related to this septic pump. And you can see I've written the cash flow diagram on the whiteboard where we have an arrow down at time 0 in the amount of $85,000. So that's the initial purchase price. And then after 8 years, the equipment can be sold for scrap. $18,500 is its salvage value. And we want to know the capital recovery. So capital recovery is just asking, what's the annual expense of operating this equipment just based on the difference between its initial acquisition and its disposal value? So we're finding the unknown annual series, and so you need to find A given P for I equals, in this problem, what's it say? 8% again. 8%. N equals 6. So we're going to do that times 85,000. And that's, by the way, negative 85,000 because it's an expense. And then we're going to combine it with find A given F. I equals 8%. N equals 6. So we're going to take this to the annual series, multiplied by 18,500, but that's positive because it's a revenue. So the difference between the inflow and the outflow is the capital recovery. So let's find out how much it costs each year to own the equipment. This isn't talking about the fuel, the insurance, wear and tear, oil changes, none of that. It's not the operating costs. It's simply just the cost of owning it, taking into account the difference between the acquisition and disposal.
What was the answer to the last one again?
The last one was 3,050,000. Do I need to leave this solution up? Okay, so back to this one, problem 2. Well, no, I guess it's problem 4. So capital recovery is minus of the purchase price taken to an annual series plus the salvage value taken to an annual series. So 85,000 is the purchase price. All you have to do is look up the factor, find A given P factor, and then add it to the salvage value where you're finding A given F factor. And it looks like on this one at least I did round off to 5 digits. 1, 2, 3, 4, 5. All right, now the last question on there was your company spends $85 million to build a bridge that will last forever. If the interest rate is 4.7%, what is the capital recovery? So this is an infinite investment. So the capital recovery is just the purchase price at the present multiplied by the interest rate. So what you'd need to do is you need to collect $3,995,000 each year in revenue in order to justify that initial purchase price. So that's kind of the implication of that is you could think about the amount of tolls that have to be collected or the amount of benefit that bridge has to be doing to justify its initial purchase. So you just simply multiply the initial purchase price by I. All right, I know that was a lot. We did 5 problems today, but I hope that those will be useful in giving you some additional practice for the homework assignment. Do you have a question?
Yeah, it's a dumb question, but company spends A5,
Mhm.
right? It spends, right?
Yeah.
So why is it positive?
Why is the capital recovery positive?
Yeah.
That's a really good question. That's not a dumb question. I'm glad that you asked that. Because capital recovery, by definition, is, it's kind of, we already know it's an outflow. So capital recovery, by definition, is an outflow. And so it's just, it's the amount of money that you would have to have as the equivalent to take into account the purchase price and the salvage. So, yeah, I guess it's just, by definition, capital recovery is always a positive value. Yeah. All right, well, I'll see you on Thursday.